Assalamualaikum. My name is Muhammad Ikhwan bin Ismail and my friend is Amirul Daniel bin Abdullah and Akil Najwa Hadin bin Eddie Hafiz. Our topic is smart parking meter. This is an introduction. A smart parking meter is an automated system designed by efficiently manage vehicle parking in public and private area. Unlike traditional parking meters, this system uses sensors and digital technology to detect parked vehicle, accept electronic payment, monitor parking duration, and alert users when time is expired. The goal is to make parking more convenient for drivers while reducing manual supervision and enforcing time limits effectively. It helps improve traffic flow, maximize space usage, and support smart city infrastructure. This is our objective. The primary objective of this project is to design, simulate, and implement a smart parking meter system using digital logic design techniques in quarters 2. This system aims to replicate the functionality of a real-world parking meter by utilizing a combination of sequential logic circuits, state machine, and input or output logic. The smart parking meter will detect the presence of a vehicle, prompt for payment, monitor the duration of the parking session, and alert when the time expires. It will consist of clearly defined state such as idle car detected, paid and expired, transitioning based on input like car detected, coin inserted, and time expired. Through this project, students will apply concept of finite state machine to real-life scenarios, gain hands-on experience in designing synchronous digital system, use quarters 2 for schematic design, simulation and verification for digital circuits, understand the practical use of flip-flops and logic gates, Carnot maps, and timing logic in embedded system. The final system will demonstrate the real-time responsiveness, reliability, and an efficient approach to managing parking operation using purely digital hardware logics. This is our state diagram. For S0 is 0 car in the parking, S1 for 1 car in the parking, S2 for 2 car in the parking or full car. For the input is in for equal to sensor in for to detect the car in the parking, out equal to sensor out to detect the car out from the parking. If from S0, if in is equal to 1, it will go to S1. If out equal to 1, it will stay at the S0. From S1, if it in equals to 1, it will go to S2. If it out equals to 1, it will go to S0. If it from S2, if out equals to 1, it will go to S1. If it in equals to 1, it will stay at S2 because the car parking is full.
Okay, next we get the methodology state table. The we obtained from the state diagram in the previous slide. It shows the current state and the next state in the state table. Next, we get the K map that we obtained from the state table in the previous slide. Next, there is a methodology circuit. The circuit in this circuit it shows 3 input with 3 inverter. We use 4 AND gate with 2 NOR gate. And then we use 3 D flip-flop with 1 output. This circuit acts like a mini computer for a parking lot. It detects when a car enters or exits. Check if the user paid and remember which spots are taken. It helps automate and display parking slot availability, like those green and red lights you see in smart parking garage. And this is the waveform that we obtained from the circuit. There are 3 input A, B, C, and then the output which shows 1 when a car enter and 0 when the car exits from the parking slot. This waveform shows how the smart parking circuit responds to car entering, paying, and exiting. When a car enters and pay A equal to 1 and C equal to 1, the system marks the slot as occupied, out equal to 1. When the car exits B equal to 1, the system reset the slot out equal to 0. The flip-flop values Q0 and Q1 helps the system remember whether a slot is occupied or not.
So from all of that, the most important aspects of the design was minimizing the logic to reduce gate usage and optimize efficiency, which is essential in hardware-based system where resources are limited. To minimize the logic we can achieve through the Boolean algebra and K-map simplification. The smart parking meter provide insight into the real world embedded system like sensors, RFID or network connectivity. In conclusion, the project successfully demonstrates use of digital system design in solving everyday problems. It also reinforces theoretical knowledge with hands-on practical experience. So the impact of smart parking meter in the community is 1. Improve traffic flow. Smart parking meters have reduced the time drivers spend searching for available parking spot. When paired with sensor and availability displays, they guide drivers to open space, minimizing unnecessary driving and improving overall traffic condition. 2. Efficient space utilization. By enforcing time limits and encouraging turnover, smart meters ensure that parking spaces are not occupied longer than necessary. This increases availability for other users, especially in high-demand areas like city centers, hospitals, and campuses. Number 3 is enhanced revenue collection. Digital parking meters can automate the payment process, reducing manual enforcement and increasing accountability. This allows local government to collect parking fees more accurately and efficiently, which can be reinvested into public service or infrastructure. Number 4 is environmental benefits. Reducing the time spent driving around in search of parking directly contributes to lower fuel consumption and greenhouse gas emission. Over time, this can support a cleaner and more sustainable urban environment. Number 5 is convenience for drivers. Smart meters equipped with digital display and timers provide real-time feedback to users. Some systems may also support mobile payment or alerts, making parking a more user-friendly experience. Number 6 is encouragement of smart city initiative. Deploying smart meters is a step toward broader smart city infrastructure. They can integrate with other systems like traffic management, public transport, or enforcement tool to create a more connected, intelligent, and responsive city. Number 7 is promoting fairness and order with automatic park time tracking and alert mechanisms. Smart parking meters help enforce rules fairly and consistently. This reduces dispute, illegal parking, and unfair advantage for certain users. The conclusion is the smart parking meter project demonstrates how digital system can be used to solve real-world problems through automation and logic-based design. By using tools like Quarters 2, along with state machine, flip-flops, and combinational logic, we successfully built a functional system that simulates the core features of real parking meter. Other than that, this project not only enhance our understanding of sequential circuit design but also showed how digital technology can improve efficiency, convenience and resource management in everyday life. Overall, the smart parking meter is a practical example of how digital system can contribute to smarter, more organized communities. That's all from us. Thank you.